All right, so we're going to do a quick refresher. So the next question we're going to answer is, where do the ordered pairs on the unit circle come from? Before we do that, we're going to go back to a couple special triangles that you talked about in geometry and probably have talked about since. They're the 45-45-90 triangle and the 30-60-90 triangle. And there's some relationships that you developed in the past where if you knew the hypotenuse, say, here, right, that you actually knew on the 44-45-90 that whatever that hypotenuse is, the two legs were root 2 over 2 times the hypotenuse. Okay. Similarly, over here in the 30-60-90, if you knew the hypotenuse, the one opposite of 30 would be half of the hypotenuse, and the one opposite 60 would be root 3 over 2 times the hypotenuse. And so we're going to use these special right triangles that we actually know about to take a look at how we are coming up with the ordered pairs that we see in the unit circle. Okay, so we're going to talk about the first quadrant. Okay, and the first quadrant, the first kind of important angle after 0 is at pi over 6. And so what I'm going to do is draw in a triangle. So I'm going to connect the origin to where that angle is, and then I'm going to drop a perpendicular line down. And pi over 6, remember I told you to be thinking in radians. However, if you work backwards, it is the same thing as 30 degrees, right? And so this angle of pi over 6, which is the same as 30, means that this 90-degree angle and this must be a 60, right? And so this triangle that we just drew is the same as this triangle right here. Okay, so I'm kind of using this. And so the important way for me to use the special relationships in the 30-60-90 is for me to know the hypotenuse. Okay, and the hypotenuse would be this distance right here. Okay, well, this is called the unit circle because one unit is 1, right? And so the radius of this circle is always 1. Well, as soon as I know that, then I know the other pieces, right? The opposite side of the 30 degrees, right, must be this y distance because it's going up and down, and that has to be half of the hypotenuse. Well, what's half of 1? 1. Okay, and then this distance, right, going left and right from the origin, that must be an x, right? That distance would be opposite the 60-degree angle, which is root 3 over 2 times the hypotenuse. Well, the hypotenuse is 1. And so all of a sudden, we have the ordered pair at the angle pi over 6 of root 3 over 2, comma, 1/2. Okay, and that's from knowing that special relationship in the triangle. Let's just make sure this makes sense, right? If I know that this is the unit circle, right, that means on the x value, I'm getting an x value that's pretty close to 1. Well, if you look at the x value right here, that is pretty close to 1. In fact, 1 is right there. As opposed to my y value, if I go over on the y-axis, right, is it 1/2? It's about halfway. Obviously, my drawing is not perfect. And so that makes sense that that would be the ordered pair on the plane. Okay, all right, so let's go and we're going to do another angle. Now we'll do at pi over 4. Okay, so I'm going to follow kind of a similar strategy, hopefully here, where I'm going to start at the origin. And I am going to connect it up to the angle, and then I am going to drop a perpendicular, try that again, down to the x-axis. Okay. All right. That means this is pi over 4. Well, pi over 4 is the same thing as 45 degrees, and so what has happened, right, is that we're actually dealing with this triangle. Right, so those relationships are true. Again, the hypotenuse here, right, starts at the center and goes out, that's 1. And so this would be x, this would be y. Well, that's just root 2 over 2 times the hypotenuse of 1. And here the vertical distance would be root 2 over 2 times the hypotenuse of 1. And so this ordered pair is root 2 over 2, comma, root 2 over 2. Okay. So that's what that ordered pair would be. Okay, we're going to do the same thing, except this time we're going to do it at pi over 3. Okay, let's see if I can actually make this happen. Gotta be a little bit more careful, apparently. Okay. Then I'm going to drop that perpendicular down. So this is pi over 3, which is the same thing as 60 degrees. And so this must be my 30 degrees. And so I'm back to having a 30, 60, 90 triangle. Okay. Again, the hypotenuse over here is 1. Well, opposite of the 60-degree angle, right? So opposite of the 60-degree angle is where we get root 3 over 2. So root 3 over 2 times the hypotenuse of 1. And opposite of the 30-degree angle, we get that it's half of the hypotenuse, which is 1. And so this ordered pair, thinking about ordered pairs x and y, has to be 1/2 root 3 over 2. Okay. Also in the first quadrant, right here, obviously if this is the unit circle, this distance is 1, so I'm 1 on the x, 0 on the y. And similarly up here, right, if this is going to be a radius, this has to be a radius of length 1. It's only going up vertically, it's not going side to side at all. And so that's why that's the ordered pair 0, 1. Okay. And so then the question becomes, all right, which ordered pairs should you know? Okay, and my answer to you is going to be that you should know all of them for the angles that I expect you to know. And so in the previous video, we went through what angles I expect you to know. And the good news is once you know the first quadrant, you can use reflection to get all the other ones. Okay, we know in quadrant 1, both x and y are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, they are both negative, and in quadrant 4, x is positive and y is negative. And so I can use some reflection as soon as I understand where they're coming from in the others. So you can see here is the completed unit circle, okay? And if I reflect, let's kind of just match some stuff up here. Pi over 6 and 5 pi over 6 have to have the same values, and they do, except the x value is negative over here because it's in the second quadrant, okay? Likewise, for instance, pi over 3 and 5 pi over 3. If I fold it along the x-axis, they have to match up, and so they have the same ordered pairs, except the y value is negative because it's in the fourth quadrant, right? And so you were able to use a lot of symmetry here. As long as you know what's going on in this first quadrant, you can use symmetry to get anything you need in the other quadrants without too much of a hassle. And if you struggle to remember that, check out the next video.